Okay, so back now we're pulling numbers from a general box, and we could estimate that if n is big, then SD of the sample, should be close to the SD of the box. Okay, I'm not going to make this a quantitative statement, but just sort of if the sample is sufficiently large, then this ought to be a good approximation of that. So that leads to this general notion of S star is equal to the SD of the sample. And this is commonly used in sampling from a 0-1 box to estimate the SD of the box. It turns out that something slightly different is typically used if you're drawing from a box that isn't a 0-1 box. And instead of this, what's used is the following, which is called S, which is the sample SD. And it's equal to basically S star times root n over n minus 1. Okay, let me write out what that definition gives us. And those of you who have had statistics before are used to calling this the standard deviation. Okay, so S is, if we have a list of data, x1 up to xn, and let's say that the mean m is equal to x1 plus x2 plus so forth plus xn divided by n. That's the sample mean. Then the way we form S is we start by taking the residuals between the data and the sample mean, squaring them. Okay, and we want the RMS of the residuals. If we were taking the ordinary SD, we would be dividing this by n, right, to find the mean of the squares, and then we would take the square root of that. The difference between S star and S is that with S, instead of dividing by n, we divide by n minus 1. And then we take the square root of the result. Okay, so this thing with n minus 1 in the denominator is what many of you have seen before as the standard deviation, but it's actually the sample standard deviation. Notice that the sample standard deviation is not the standard deviation of the sample. They differ by a little bit. If n is really, really, really big, then this ratio is going to be almost 1, right? The limit of this ratio as n goes to infinity is 1. Right? If n is small, then this thing is going to can be noticeably bigger than 1. So this sample standard deviation is bigger than the standard deviation of the sample by an amount that gets smaller the larger the sample is.